Hello dear student, so we will discuss the next topic from the chapter of some basic principles and techniques of organic chemistry. The topic that we are going to discuss today is very important for our JEE NEET examination, where you can expect question from this particular topic. The topic that we are going to cover in this class is hyperconjugation. So my dear students, without getting late, we will discuss what is hyperconjugation. It seems interesting, right? So let us understand what is hyperconjugation. Before going to talk about the hyperconjugation, the definition is like this, my dear student. The first definition or the definition of hyperconjugation is nothing but it is the delocalization of electrons from a sigma bond. From where? From sigma bond to an adjacent empty or partially filled orbital. Here, the definition is saying that hyperconjugation is a phenomenon in which delocalization of electrons of sigma bond to the adjacent half-filled or empty orbitals. My dear students, delocalization in the terms, to understand it very clearly, we can say it is like shifting of electrons. We will shift, the electrons are shifted. Which electrons, my dear student? It is sigma bond electrons. It is shifted to the adjacent empty or partially filled. Sigma bond is usually seen where the first bond, which is always formed in between carbon and hydrogen or carbon and carbon. Alright, so see here, if a single bond is formed, then it is which bond, my dear student? It is sigma bond. And if it is double bond, the second bond which is formed, it must be a pi bond. And the sigma bond contains which electrons? Sigma electrons. And pi bond contains pi electrons. This is the term we have to clear about this particular hyperconjugation. And now, my dear students, I need to also explain another term for this particular topic, that is nothing but alpha carbon. What is alpha carbon? And what is alpha hydrogen? Now, my dear students, see here, there is CH2 double bond CH2 bond CH3. What is alpha carbon? The alpha carbon is the carbon which is attached to the functional adjacent group. Let me repeat again. The alpha carbon is the carbon which is attached to the adjacent functional group. Now, my dear students, look out here. Here the functional group is an alkene. It is an alkene, right? It is a functional group. Okay, it is a functional group. Here the carbon here which is adjacent to the functional group is nothing but a alpha carbon. Is it right? Now, my dear student, now you understood what is alpha carbon. Now, what is alpha hydrogen? The alpha hydrogen is the hydrogen which is attached to the alpha carbon. Now, if you look at this particular CH3, how it will be, my dear student? It will be in the form of like this, in a structural way. You can go like this, right? So, it will be CH3, right? It is CH3, and as usually CH2 double bond, CH2 double bond, CH2 bond. Okay, this is alpha carbon. Okay, this is alpha carbon, and this hydrogen is alpha hydrogen. This one is also alpha hydrogen. This one is also alpha hydrogen. So total number of alpha hydrogens here is 3 alpha hydrogens. Now you are clear, my dear students. Now, my dear students, here what I need to say is, this is the concept that we need to understand. So for occurrence of hyperconjugation, the most important thing is alpha hydrogens are necessary, and the alpha hydrogen is necessary for hyperconjugation, and as well as the vacant orbital, which is equal to hyperconjugation. My dear students, here the delocalization of electrons from a sigma bond to the adjacent empty or partially filled orbital. That means alpha hydrogens play a very important role in hyperconjugation. Now I will explain, okay, what is the mechanism of hyperconjugation. Now, my dear student, listen carefully here. Now I am taking a CH3 and CH2, okay, and this is a carbocation. Now, my dear student, now this becomes the alpha carbon, and this is alpha hydrogen. Now here we are having what? Being a carbocation, it is represent to have a vacant orbitals. So in this case, my dear students, in this case what happens here is, here the hyperconjugation can be happen. Now look at this, here there are sigma bonds, because here single bond, that is sigma bond, sigma bond, sigma bond. So the alpha hydrogen here will shift the electrons, the pi bond electrons of C bond H, that means this one, C bond H pi electrons are shifted to the adjacent empty orbital. Okay, here this happens because of the presence of the alpha hydrogen in which a unsaturated system. Okay, so here the electron is shifted to the vacant p orbital. So here particularly the carbon is p orbital. So here in the p orbital the electrons is shifted to the nearest adjacent carbon, which is empty orbital. So after this, how can the structure can be seen, my dear student? Now look at here. The structure can be in such a way like this. Here hydrogen is plus now, and here we are having a carbon with a electron, sigma bond electron. Okay, right? So this is how the mechanism will go, right? So here there is also a possibility, my dear student, from this electrons here we can also donate, and here this is also an alpha hydrogen where the electron can also be donated here, right? That means the shifting of electrons can be movement to the next adjacent carbon. Clear? Now my dear students, I hope you are so clear about this mechanism of hyperconjugation. Now involves overlapping of what? It is involves overlapping of sigma CH bonds, that means the CH bonds, sigma bonds with the adjacent pi or p orbitals. That involves the mechanism of hyperconjugation. So far we have discussed. And electron delocalization, that means electron delocalization means increased molecular stability. You have also seen in the hydrocarbon chapter where the resonance structure of benzene, more the resonating structures, more will be the stability. Now my dear students, here come the uses of the hyperconjugation, where when electron delocalization happens more, then it increases the molecular stability. Now example for this is alkane stability influenced by the hyperconjugation. So in an alkane, when alpha hydrogens induces the hyperconjugation, that means resonating structures, that means the stability of the alkenes will be increased. Now hyperconjugation, it involves delocalization of sigma bond electrons of CH bond of an alkyl group attached to the atom of unsaturated system. So my dear students, once again look at here very quickly. So this is CH3CH2, it is ethyl carbocation. Now look at this, this is having CH carbocation. Now which one is the alpha carbon here? This is the alpha carbon and this is the alpha hydrogens. Now look at here, the electrons, that means the shifting of electrons of the sigma bond electrons to the adjacent half filled or empty vacant orbitals of the next carbon. So look at here, this happens here. Now look at it. If the electrons are shifted here, now this becomes cation and here double bond is formed. And look at the next one, H plus. That means if this carbon is donated here, then it becomes here once again. And if this hydrogen, in case this hydrogen, if it shifts the electrons, sigma bond electrons to the next, it becomes a next resonating structures. Now look at here, how many resonating structures have been from 1, 2, 3. So that means 3 more stability. That means it has formed 3 resonating structures. So this is how the stability of the molecule can be predicted. So it explains the stability of carbocation, free radicals, and also the alkenes. And my dear students, keep in the mind, hyperconjugation is also called as, no bond resonance. It is called as no bond resonance. Now my dear students, why it is called as no bond resonance? Here the resonance happening, but there is no bond. Here the resonance happening, but there is no bond. Here there is no bond. Here the resonance happening, but there is no bond. So that is why it is called as no bond resonance. Hyperconjugation is also called as no bond resonance, where you can see a resonance happening where in the absence of a bond formation. Now let it go into play. Now what is types of hyperconjugations? My dear students, hyperconjugation is of two types. First one is positive hyperconjugation and negative hyperconjugation. Generally, positive hyperconjugation is seen in carbocations in the case we have already discussed. And negative hyperconjugation is also seen in the case where electron withdrawing groups are present. Where the electron withdrawing groups is present, there also you can see a hyperconjugation, but in a negative way. Now, hyperconjugation gives us the information of what, my dear student? What are the applications of hyperconjugation? The first application is stability order of carbocations. It explains the stability order of carbocations. So CH3C plus, here is a carbocation, here is also carbocation, here is also carbocation. Now look at my dear students, more alpha hydrogens is directly proportional to more stability. Okay, that means more number of alpha hydrogens are present. It means more hyperconjugation can be happened, because that is, if there is 4 alpha hydrogens, 4 resonating structures can be happened. If there is 6 alpha hydrogens, 6 resonating structure happens. Now in the case, now look at this, we are having how many alpha hydrogens here? 6 alpha hydrogens. Here, look at here, we have had CH3 molecules, 3 are there. Here 3 CH3 molecules, there are 2, and here is only 1. That means alkyl group, here the number of alkyl groups are here, it is more. That means number of alpha carbons are more. Number of alpha carbons are more means number of alpha hydrogens are more. Number of alpha hydrogens are more means more will be the stability. So in this case, that is why tertiary carbocation is greater in stability and secondary carbocation than primary carbocation. So this is how we can understand the stability of an alkene with the help of the hyperconjugation. Clear? Now, more alkyl groups, more hyperconjugation, more stable. Clear? That is what I want to say you clearly. So it is seen in alkane stability and aromatic substitutions. Now, what is the summary of this class, my dear students? It is hyperconjugation, that is equals to electron delocalization of sigma bonds. If whenever you listen the name of hyperconjugation, it is nothing but a delocalization of sigma bonds. Next, it stabilizes alkanes, carbocations, and radicals. Next, explains the reactivity and structural effect. It explains the reactivity and structural. Now, what is the final synopsis? That whatever you have learned here is hyperconjugation is nothing but the shifting of sigma electrons to the pi or p orbital electrons delocalization. It explains the stability of carbocations, alkenes, and free radicals. And remember, always remember, that is more hyperconjugation, more is the stability. Now, my dear students, let us try to understand how the questions will be appeared in our JEE NEET examination. The first question that we are going to see here, this question was asked in a previous JEE NEET examination. Now let us try to read the question. The correct order of stability of a given carbocation is, now we need to find out the order of stability. Now which is more stable, that we have to find out. Now look at the picture here. Now we are having the A, B, C, D molecules. Now we need to find out which particular molecule is having more alpha hydrogens, because order of stability they are given. We have seen just now, more the number of alpha hydrogens, more will be the stability. Now look at here, here this is a functional group, here we are having CH2, here one alpha carbon, here also one CH2. That means we are having 2 to 4 H, 4 alpha hydrogens. Clear? Carbocation, here it is functional group alkene. This is alpha carbon, we are having how many? 2 hydrogens, 2 alpha hydrogens. CH3, CH2. Okay. Now look at here, we are having 3. Because this becomes alpha carbon and this is the 3 alpha hydrogens. So we are having 3 alpha hydrogens. Coming to the option D, here we are having only 1 alpha hydrogen. So my dear students, now come from highest to lowest. So first comes A is greater than, next comes C, next comes B, and next comes D. Now let us check the options here and we will pick out the correct option according to the given question. Now Option A, B, C, D. Now look at this, my dear student. A, C, B, D. Okay, A, C, B, D. Yes, option A is our correct answer. So this is our correct answer. Now let us go with the next question. Now look at this question is from the NEET examination. Now hyperconjugation involves delocalization of. Now this question is asked for NEET examination. Now let us see. The question is asking hyperconjugation involves delocalization of. The first option here. Electrons of carbon hydrogen sigma bond. Yes, electrons of carbon hydrogen sigma bond of an alkyl group directly attached to an atom of unsaturated state. Yes, this is correct because that is the definition of our hyperconjugation. Next, electrons of carbon hydrogen sigma bond of an alkyl group directly attached to the positively charged carbocation. Yes, positively charged carbon atom means carbocation. Yes, this can also be possible. This one is also correct. Next, pi electrons of carbon-carbon bond. No. Hyperconjugation is always talk about sigma bond electrons. It is not pi. So I will not take this as a correct definition. Now, lone pair of electrons. We doesn't talk about lone pair of electrons. Only the sigma bond electrons. So here we can see that option 1 and 2 will be the correct involved in the hyperconjugation. So here option 1 and 2, okay, option A will be the correct answer, my dear students. So that's it. So this is how about hyperconjugations. I hope you are clear about this particular topic. Thank you.